We'll talk now about irrigation and fertilization of greenhouse cucumbers. It's a well-known fact that the cucumber is a high demanding crop regarding irrigation and the fertility of the soil, and therefore we can achieve good yields, high yields, only by providing enough water and fertilizers during the entire growing period of the cucumber crop. As you can see from this graph here, the crop coefficients of the cucumber crop are fluctuating, are different in different stage of its development, and it is also depending on the level of the salinity in the irrigation water. And practically you can see that there is a constant and a rapid increase of crop coefficient in the first 45 days after transplanting, and practically the crop coefficients values range from 0.19, 0.22 and 0.06 respectively first, second and third level of salinity at day 5 after transplanting, and then they are increasing up until at the day 45 after transplanting they reach respectively 1.49, 1.44 and 1.41 respectively for S1, S2 and S3. Then between day 55 and day after transplanting 105, the crop coefficients are oscillating, and the mean values are respectively to S1, S2, and S3, 1.49, 1.45 and 1.26. And then after this day, after 105 days after transplanting, the crop coefficient values are significantly reduced to the level of from 0.7 and 0.44 respectively for S1 and S2. So this is an indication of how the crop coefficients are changing, and accordingly how the crop water demands are also changing from another stage of development to the next one. And of course in the first 45 days after transplanting, usually mostly we have only vegetative growth of the plant, and this period 40 to 45 days after transplanting we have the first fruits harvested from cucumber crop, and because of that the crop coefficient values are significantly increased comparing to day 5 after transplanting. Anyway, to obtain high yields and adequate water supply is required during the total growing period of cucumber, and any potential reduction in water supply during the entire growing period will have a significant adverse effect on yield. So it will be followed by great reduction in fruit setting. There will be a lot of flower drops, but also it is expected that because of the water stresses, the number of female flowers to be significantly reduced in the subsequent plant nodes. Therefore, we have to be careful and supply with enough water the cucumber crop the entire growing period. On the other side, have to be careful to ensure that we will have a good drainage rate in order that excess water to be removed out of the root zone. Otherwise, plants will suffer from the lack of air, from the lack of oxygen, and it might be with serious consequences on plants' life and expected yield. The cucumber crop is also a very high demanding crop regarding the soil fertility, and we could obtain good yields only if we supply with enough nutrients. As you can see from the graph here, at the start until day 13 after transplanting, the plant requirements for nitrogen, phosphorus and potassium are modest and not so high, but from this day on we'll have a quick increase of plant demand respectively for nitrogen and potassium, which reach their maximum after day 45 and on. But we do not have the same shape of the phosphorus demands, and as you can see from the graph here, it is more or less stable since the day 20 and after transplanting and on. Again, the most demanded nutrient element is potassium, and but as you'll see in the following table, still the ratio of nitrogen with potassium is smaller than, for example, tomato crop in Solanaceae family, but also much smaller than the respective ratio in, for example, a melon and watermelons, which belongs to the same family with cucumber. But a more clear picture, more detailed information about the nutrient requirements of the cucumber crop you might see in this table, which expresses the recommended nutrient demands in kilograms per hectare for a cucumber, for a greenhouse cucumber grown under natural soil. And as you can see here, it is the demands are changing and gradually increasing from the stage of the vegetative development to fruit set and fruit development. And in total, you can see that there is a total demand of about 335 kilograms of nitrogen, and it is estimated to be almost 370 kilograms of potassium per hectare, and obviously can see that the ratio of nitrogen to potassium is almost 1 to 1, and this is a great difference comparing to tomato, but also melon and watermelon, as I explained before. And this means that in order to have good yield, you have to provide good amounts of nitrogen fertilizers, and this is understandable if we consider that we consume the cucumber fruit as immatured, and therefore the rate of fruit setting and consequently the rate of fruit harvesting will be highly depending on the growth rate of plants. Thus, by providing more nitrogen, we are able to provide a faster growth rate of the tomato or sort of cucumber plants, and consequently a larger number of fruit is expected to be set and to be harvested. There is a less demand regarding for phosphorus. It's about 170 kilograms per hectare, and even less. There are other references which are suggesting that even less phosphorus is demanded by cucumber plant, especially at the production period. And you can see from the table here that starting from week 6 and 7, the amount of the demand for phosphorus fertilizer is reduced a lot, and remained like that entire period, and it is just under half of the weekly amount of nitrogen and potassium. And this is something that has to be considered during the fertilization of greenhouse cucumbers. It's very important. This is a very important and very informative table to be used. Of course, that we can also fertigate the cucumber crop based on the proportional method, like for the other crops. And in such a case, this table, the information provided by this table can be used. You can see that first there is about in the period of stand establishment up to 25 days after transplanting, an average of 25 cubic meters per hectare per day is expected plus irrigation demands, and which is later on increased to 40 and 55 and even 60 cubic meters per hectare per day, and starting from the vegetative stage to flowering and finally to fruit production. And so you can see that the concentration of the nutrient elements is different, and the highest concentration are demanding for potassium from 0.1 to 0.12 kilograms potassium per cubic meter, and which is twice more than the amount of nitrogen fertilizers, and much more, 5 to 6 times more compared to phosphorus. And it is obvious that by increasing the volume of irrigation water from 25 to 40 and then to 60, even by maintaining the same concentration of these main nutrient elements, you are providing a higher amount of nutrients, simply because you are providing more nutrient solution to the plants. And of course, we explained that before, that by using the proportional method, we adjust the total amount of fertilizer supplied to the plant with the respective amount of irrigation water, and thus you increase the efficiency of use of both the water and the fertilizers. So this might be the best method of fertigating any greenhouse crop. You can use the table which is presented here as recommendations for the nutrient concentration in soilless greenhouse cucumber, and you can see it here that the concentrations of any of these fertilizers is changing from the first week and gradually increasing from the first week until the harvesting period. And you might see that we have a relatively stable concentration. The values here are expressed in ppm or in milligrams per liter, and we have a stable concentration of ammonia, which is up to 25 ppm, while the concentration of nitrogen nitrate is gradually increasing. And similarly, we have also a gradual increase of potassium fertilizers, as you can see from this table here. And meantime, we should say that the concentration of the micronutrients remains stable entire growing period. There is not any change, no any increase due to the in different stages of plant development. However, the total electrical conductivity of the nutrient solution is gradually increased from 1.94 at the start until 2.5 or 2.76 even at the period from week 8 to week 11 after transplanting. And this is the maximum, and then it is gradually decreased again because of the reduction in the amount of fertilizers used, both of potassium especially and so nitrogen. Again, this is just a recommendation, and you need to adjust it respectively in accordance to your specific growing environment and plant situation and weather situation and things like that. And like for the other crops, the best method to estimate whether the respective fertilizer program is correct or not would be the estimation or the evaluation of the respective concentration of main nutrient elements in cucumber plants with the recommended range of these nutrient elements. And practically in this table here you can find what are the normal concentrations of nitrogen, phosphorus, potassium and so on in as expressed as percentage in dry matter of cucumber plants. And depending on your respective values, you might either continue the same fertilization program or respectively add or reduce a certain nutrient elements in order to feed it better with these recommendations of each of the main nutrient elements. This should be the best method. But as I also said before, still there is not enough quick and reliable testing methods in terms of cost and delivery of information to the growers. So still, most of the times these values remain for experimental purposes, for scientific purposes. They are not yet really used or daily used in the commercial cucumber production.